Welcome to Decision Analyst Insider Series webinar on machine learning segmentation in the digital age. My name is Christy Allen. I am the Marketing Director at Decision Analyst and the moderator today. Before I introduce our presenters, I have a few notes for everyone. There are some relevant white papers and case studies in the handout section available for everyone to download. Also, please feel free to ask any questions by typing in the chat box. We will attempt to answer as many questions as we can at the end of the presentation. If we don't answer your question during the webinar, someone will respond to your question within a day or two. Today's presenters are Dustin Cannon, Manager of Database Analytics at the Dallas Morning News. Dustin has over 20 years of experience in planning, coordination, and executing complex research to solve marketing issues. And John Collius, Senior Vice President at Decision Analyst, is co-presenting. John has more than 30 years of experience applying statistical models and methods and helping businesses optimize their marketing programs, products, strategies, and pricing. And with that, I will hand the presentation over to John.
Thank you, Christy. So to begin with, as we know, traditionally segmentation is a method that's used to group customers into groups that are as homogeneous as possible. And that grouping is done based upon the needs of the customers, the benefits sought. Needs, for example, could be a need for convenience, or benefits could be a benefit could be a need for reliability. But then there are more concrete product attributes themselves that are part of, can be used for grouping customers and their preferences for those features of products. For example, with the food product, it could be the ingredient of the food itself could be a feature that is being used, and what preferences people have for ingredients can be used to group people into homogeneous groups. It might be the amount of time for travel from terminal to terminal at an airport could be another product preference that customers have. And loyalty behaviors, how strongly people tend to stick with a certain brand and how strongly they feel about a certain brand is something that differs across people and can be used to group people. And channel usage, we've had an explosion of different types of channels in the recent years and in the past decade with the growth of social media, which and different people use different channels more frequently than other channels, and that can be used as well to group customers into segments. And so these needs and benefits sought and product preferences are really used, leveraged to devise and organize marketing activities. So, for example, advertising what new products are being developed, advertising that would resonate with people's needs and benefits that they're seeking, new products that would offer, meet those needs and provide those benefits, promotions that again resonate with what the consumer is looking for, and channel differentiation, pricing, branding, positioning. All of these are things that can be developed based upon the needs and benefits and product preferences sought, and different things are used to do that based upon those needs. And the ultimate goal, of course, is acquisition of new customers, retention, loyalty, cross-selling. Those are typical goals that are trying to be met by leveraging the segmentation and understanding the customers and how they operate. So that's traditional segmentation. Of course, the available data historically that was used for this were products purchased that came from CRM systems, for example, demographics. The Census Bureau in particular developed the census survey, and that began to be used. It was eventually developed and brought down to the census block group level so that you can get 5-year averages of demographics for consumers at the block group level and household characteristics and so forth. And those that kind of data, there's over 220,000 block groups in the United States, and coming down to that level of geography allowed some clustering to be done. Firmographics has been available, such as locations, number of locations of businesses, where they're located, number of employees, things of that sort from public databases. And then surveys, attitudes, and lifestyle questions that are asked in surveys. And there was an effort to try to, as we all know, to try to link those attitudes and lifestyle behaviors from survey questions to the demographics themselves, and in particular by geography, which developed methods like prison codes and tapestry codes. And all of that, again, was used to hopefully correlate with the demographics and the firmographics, or the product purchase patterns, geography, with needs, benefits, and sought and product preferences. And then at the same time as that his kind of segmentation has been going on for a long time, new data sources were coming into to play, and technology was growing over the past couple of decades. And e-commerce, as we know, has been a disruption, for example, in a big way in the retail markets. Web scraping has been able to generate large amounts of big data. Pools and data aggregators have developed to produce this new kind of data from that. And the Internet of Things is only making that even greater. So as you have home devices that are connected to the Internet, and automobiles are connected to Internet, health devices that are connected to the Internet, all of that is producing large amounts of data that can then be used with machine learning methods. And so at the same time that this technology has been developed above, the machine learning methods were being developed. And in particular, these ensemble models, bootstrap aggregation, random forest, and boosting models, the latter three of these were pretty much developed in the 1990s. So if you were in school and learning about these things before the 1990s, they didn't really, these methods, these techniques, many of them didn't even exist. And so at the same time, artificial intelligence has been in development for a long time. So when I was in graduate school, even in the early 1980s, there were economics professors I was working with who were using artificial intelligence. That was almost 40 years ago in the field of economics. So it's been around for a long time. But these machine learning models have one of the types of models has been to expand in neural network models. And it used the foundation of the theoretical foundation of artificial intelligence, has been around for a long time, expand on that with big data and building neural network models and layers of neural network models, which produces what we call deep learning algorithms. And all of that produces an ability to process large amounts of data. So machine learning then, along with these new types of data that are available, really today provides another alternative to accomplish the same kind of goals as machine learning, as traditional segmentation. So the machine learning, again, enables us and gives us a method that can increase the models that can be used to improve acquisition of new customers, to retain customers, reduce churn, appeal to loyal customers and find those loyal customers in order to market them and keep them happy, and produce cross-selling opportunities, and ultimately the dollar sign on the bottom right. So all of that is with the goal of trying to increase the revenue and profit of the business. And so I'm going to turn it over to Dustin now, and he can talk a little bit about some of the data that were used in this analysis.
Thanks, John. This is Dustin Cannon with the Dallas Morning News. Very happy to be here with John Coleus and Decision Analyst. So let's go ahead and talk a little bit about the kind of data that we looked at when we started this project. We wanted to understand what was first available to us and see how we could potentially use it. And so here are a lot of the things that we looked at, and some of these things eventually made their way into the model, either as a direct input, but others just helped us inform the kind of data that we might want and might want to focus on. And just to go through it here real quickly, so obviously we know when people come to our website, thedallasnews.com, we're able to see what they clicked on and what links they followed. So that was valuable information. As well, we can tell where they're located, whether they're viewing from a mobile phone or from a desktop or a laptop. We're able to get that location, and so we're able to tell the difference between someone who's viewing locally versus someone who might be somewhere else in the country and just say following the Dallas Cowboys or something like that. We also have some information about the online journey as a whole. So yes, we know what they did on our website, but do we also know where they started their journey? How did they eventually come to us? Was it through a direct search, or was it from a link on a news aggregator website, or what have you? We also had done some digital online A/B tests in the past, where we looked at different things in terms of different types of content and how it could ultimately drive subscription, say. Advertising data, also knowing what kind of advertisements different types of people click on when they're on our site, what's appealing to them, even down to the placement of those ads. We also looked at newsletter registration, so not everybody necessarily goes to the website. A lot of times they're driven to the website through a newsletter, which has a list of the different articles headlining that day, and so they're able to click to it and get through it in that direction. We also looked at virality. So obviously, when we write a really great article and it really takes off and gets picked up by, say, a Google News or a Yahoo News or what have you, that can be very beneficial to us from the perspective of ad revenue, as well as expanding our reach to a broader audience. And then lastly, we also wanted to understand from a social media perspective. We know that a lot of people are getting their news nowadays through, say, a Facebook or LinkedIn or what have you. And so we wanted to understand what does it mean for the customer or the reader to start there versus other locations. And so, of course, all this with the purpose of eventually training a model and model tuning, which we're going to talk about a little bit more here in a second. But to John's earlier point, all of that leads back again to the primary goals, right? What can we do how can we use this information? How can we use a machine learning segmentation to help us acquire customers, obviously retain the ones that we have? How can we get loyalty? In fact, we're going to talk a lot more about that in a second in terms of engagement. How involved are people in the articles that we have? And then to the extent that we can sell other printed publications or online properties that we have, all the better. So as we look through all of that data, we decided to really sort of focus in on one specific thing. And right now, one of the hot topics is how do you get readers to come to your site and stay engaged? In other words, anyone who's browsed the web knows that a lot of times it's just surfing and you click one link and go quickly to another, and if you don't see anything that interests you, and so it's really not enough just to get them to our site, but also to understand what causes them to stay. And we can tell that through things like stories clicked, and then most importantly though, the engaged minutes. How long are they staying on each one of these stories? We know there are some other important factors to being an engaged reader. So for instance, is this a new customer who maybe just saw our link for the first time in a Facebook page, or is this a returning visitor who visits us regularly for their local as well as national news, say? And then there are other things that can help us classify folks. For instance, the type of device used. We know that mobile is nowadays much more important. And then as well as what I was just discussing in terms of where they clicked from. Did they start social media? Are they clicking a link that is already on our site, or are they coming to us through a search feature like Google or a search feature located on our own site? The eventual goal there, of course, is that we want to understand these journeys that people are going through in terms of not just one thing, but understanding what are the content that's ultimately driving them, and then importantly, what are the websites that they were at before that ultimately drove them here, and then attribution modeling, which is getting at trying to understand, well, how important was it that they, say, visited the New York Times before they came to our website, or how important it was that they saw, say, something on like an Axios or something like that, and how can they eventually get to us? And then we want to segment customers based on the content itself. But first, the way we're going to proceed with this, and we'll discuss this in a little bit more detail, is what role does the content play? So we want to segment the content itself first to understand what's available out there, and then how that ultimately leads to can we take those events in terms of reading content and turn that into a segment of actual customers rather than content. And then to the extent, and then after that, we want to understand, well, how are we going to do with all that information? Let's say that we have that segmentation and it seems robust and what we want. How do we then apply that? And that, of course, can be a challenge in terms of helping guide the newsroom in terms of the articles that they want to focus on, as well as promotions that we may want to have on our site. And additionally, how do we want to try to make sure that we maximize our ad revenue based on what they're coming to see? So to give you an example of what a journey looks like, this is actually an extract from one person or one case that we had, where you see the individual starts off with the New York Times, then they go to CNET, then Ars Technica, and so on. And we actually see that they don't really visit the Dallas Morning News until they get about halfway through their journey. And we want to understand, what is the role of, say, visiting the MSN website or the Huffington Post before they come to us? Did they drive us there, or is it actually they couldn't find what they wanted, say, and so they eventually landed at our site? All right, so now let's talk a little bit about the steps we took. So first, and this is not just true for machine learning, but in any methodology, right? First, you want to focus in on data gathering. What do you need? As well as the pre-processing. It's very, very rare for the data to come through in a way that's easily usable, that you can just start right off the bat without having to modify or adjust your data necessarily to make sure that you get a clean read and that it works with the technique that you're using. And then ultimately, we also went to, the second was apply machine learning to try to understand, now that we have the data together, what kind of results can we see? Can we get good fits and make solid predictions that lead to models that we can ultimately use for marketing purposes? And then lastly, it's great to have a model, but you ultimately have to communicate that to folks, and you want to make sure that the best way to do that is typically something that they can see, or model visualization, allowing people to understand quickly what insights we develop from that. So obviously you go through 1, 2, and 3 there. So let's start with the first one. So again, this is a segmentation of engagement based on the content as well as where they started their journey ultimately. So click from location and content. And what we want to try to predict is engagement, primarily engagement in terms of how long they stayed on our site reading the articles. Second, we had to do some data transformation, and we're going to show you an example of one of the ways we used a machine language algorithm to help us in that transformation itself, so that we got it right. And then also the content itself, and this is always a challenge when you're dealing with text analysis, is how do you summarize numerically words, essentially, right? What do you have to do to get some meaningful scoring from that? And so we used a sentiment algorithm that enables us to look at these tags and make a prediction on how they will be received, or how attractive they might be to potential readers. And then lastly, and again, this is very typical not just in machine language but anywhere, we wanted to make sure that we held a validation data set out, or a holdout sample, so that ultimately we can test the model that we built to see how well it performs. In this case, we started with a collection of almost 10,000, 9,711 articles, and we wanted to see if we could predict the amount of time that people spent on each one of those articles. And then lastly, like we said, use the validation data set to see how well we did in that respect. So, but now let's focus a little bit more on how we used it to just get our data the way we wanted it. So for instance, a lot of individual tags, individual words in these tags, but we know that there are a lot of words that necessarily go together. So for instance, you can see Highland Park and Oak Cliff and Fort Worth, obviously. And if you're not familiar with the Dallas area, those are places, nearby suburbs and so on. And so we wanted to make sure that we wouldn't try to take one of those words out of context, and made sure that it was always paired with the other word when necessary. But even this analysis, even though it was meant to just reduce the data down, it actually bears some insights in itself, right, in terms of what's stemming off from Dallas. We see city and hall, and so focus on politics, and then even from there it goes into business, which we know from unique page views is a very important matter. And then, of course, in Texas, sports are a huge thing, as they probably are in many other areas of the country. And so we see that there's a focus on colleges, the Sooners, the Oklahoma Cowboys, as well as Baylor Bears, and all of these things. And so we use this to make sure that we were getting the right terms in there, and that when we went to our sentiment analysis, we were looking at the right terms. All right. So now let's talk a little bit about what we actually did in terms of applying that machine language. And I'm going to turn it back over to John, who's going to talk through the random forest algorithm that we used.
Okay. So random forest is one of those machine learning methods. And what it essentially does is it builds what we call trees. And these 3 trees here are examples. And we'll go into one in a little more detail in a moment. But basically, it's like an upside down tree. The top of each one of these 3 visuals here would be the root of the tree, and the leaves are at the bottom. So it's kind of like an upside down tree, and we build many of these. And so what we do is and here's an example of just one of those trees, just to look at it a little bit more carefully. In this case, we, as Dustin said, began this analysis with trying to segment articles with the goal, as a next phase, to segment actual customers. But we're segmenting the articles that customers read, which does group, customers that read those kind of articles. And so internal referrals refers to if an article has, for example, it says greater than or equal to 8.5. If an article had on the right there, if an article has clicks of more than 8 clicks that come from some other place in the Dallas Morning News website or websites, then that article gets thrown down to the next node. And if it's greater than 56 articles, it says greater than or equal to 56.5, then that throws that article down into the leaf on the bottom right. And you notice that the box plots in here show an increasing number for, in this case, it's engagement of the customer. And so as you go down the tree from the leaves from left to right here, you see the articles are being segmented. They're being thrown into buckets where the amount of engagement is increasing from left to right. And this is an example of just one tree. In actual fact, what we do is we build many of these trees, and in this case, 1,000 trees. And so what we do is we begin with this random forest methodology does this by randomly selecting what's called a bootstrap sample, which is just a sample with replacement. So we have for round numbers, 800 articles to begin with that we're building this model off of. And we select a sample of about 2/3 of those, and we develop a tree. And then what we do is we select, and we develop that tree by selecting not all the predictors, but it says K out of 7 predictors. In this case, it was 3 out of 7 predictors. So we randomly sample articles or observations, then we randomly sample variables or predictors, and then we build a tree. And we do this over and over again 1,000 times. So we repeat these steps. And the tree on step 4 there is, you can see that it says predict non-selected articles to test the model. So the model is being tested as it's being built. There's always a holdout sample, and we're always testing the model as it's being built. And so we have a really good method to try to measure how well the model is performing. So why did we choose this kind of random forest model? Well, first of all, it's among the most accurate of machine learning models available. It's been used in competitions worldwide, competitions where a sponsor will give prize money to analysts who are around the globe competing to get the very best predictive model. It's done well in those, and part of the reason it's done well is this type of model is done well in those competitions because it's relatively immune to what we call low variance predictors, or predictors that would be hard to leverage in a traditional model. You can glean some information from it, even if it doesn't have a lot of variation out of these models. And this type of model is not limited to a linear model, like a linear regression. It builds relationships that are nonlinear with lots of interactions. It's like a free-form, no equation type kind of model. And it's relatively immune to overfitting. These are all great qualities of a model in machine learning. By overfitting, we don't want to make the model fit so well to the data we're building it on so that it no longer predicts well, because it kind of models the quirky random variations or strange variations that exist in any particular data set, but not generalizable to beyond that. So the bottom line is we select this kind of model because if website engagement can be predicted, random forest will be able to do it. And we can answer our primary research questions for this model, which is, can click from location predict well? And can the content of articles predict well? So I'll turn it back over to Dustin for some more of our results.
Okay, so let's talk about model visualization. So we've talked about the steps we took to gather all the data and how we process that. And then John just reviewed through the specific technique that we use, which is random forest modeling. So now let's talk about how we can show those results so that it makes sense to folks. And so let's look at a few things first here. So one question is, how important are these different factors? And so we see the different types of referrals here, whether it came through search or whether it was a direct link from somebody following a URL, or whether it was internal, meaning that it was a link on our own site to another place within our site, as well as the different, some of the social media places that were the most common: Facebook, Twitter, LinkedIn, and Pinterest. And then the content itself came through in that sentiment score for each article and how well it predicted. And what we can see here is the farther to the right, the more important, impactful that it was. And so obviously, kind of as expected, if somebody's searching for a particular article and they know that it came from the Dallas Morning News, then you would expect that to be the type of article that would really attract engagement, because it's something that they're specifically looking for as opposed to being served up. But we also see that direct references as well as internal referrals also have a lot to do with them ultimately getting to us. The different social media platforms, Facebook and Twitter, as you might expect, Facebook is doing the best and Twitter second. LinkedIn and Pinterest, not quite as well, but nonetheless important in determining how long they're going to stay. Sentiment is also in there, and so it's more important than, say, LinkedIn or a Pinterest. But our concern as we ran this was that sentiment might not be robust enough to necessarily capture all of the nuance, say, in a particular article. And so that's definitely something we plan to do in the next phase, is to see how we can provide a more robust scores for the different texts that we're analyzing here. All right, and so now let's go to the content itself. So, but with that, so now let's focus in on just the top 5% of articles, the ones that floated to the top and had the highest degree of engagement. And so let's look at some of those tags and see what came up as most important or most read. Now, right off the bat, you see the huge Cowboys up at the top, and that's not at all surprising. Our sports section is far and away the most visited site on our section, but even here we garnered some insights in terms of high schools. So we hadn't really predicted that there might be that much coverage or desire for coverage for high school sports. And in fact, as a result of this research, we did some work to improve the high school coverage that we have, as well as things like live streaming some of the local high school games. And then you see other areas, right? Like so crime, and then of course the Texas Rangers, not as impactful as the Cowboys, but still important there. And even if you look to the right, maybe midway down, you'll see the word Harvey written there. This analysis was done a couple of months after Hurricane Harvey, and so that was obviously on the top of mind of many folks and floated to the top as something as the type of article that engaged our readers. So how did we do? Does the model that we built based on the content as well as as where they start, is it a good predictor of how long they stay on the site? And we actually see that the model does a very good job of that in terms of the predicted minutes as well as the actual minutes. Now we took the log here since these are nonlinear values, so just to make sure that we could see how they fell along a linear prediction line. We took the log of both to see that. And you see that while there certainly are some outliers here and there, by and large, the predicted meets the actual quite well. So now let's talk a little bit about where do we want to go from here? So one thing we want to do is expand on this segmentation to get even more of the online news journey. So instead of a focus necessarily on our site and maybe the site that they came to right from us, we can really dig into more of that entire journey and really understand as these other sites directed folks to us, how does that predict their level of engagement? Obviously, we can segment customers from this. So before we segmented based on content, but there are methods within machine learning where you can take those segments and pull those into segmentation of customers themselves. And this could be very interesting if we see, for instance, that different times of day may cause people to look for different types of content. You can imagine, say, someone at work visiting our site for information concerning their profession versus maybe going home later that night and focusing more on the Dallas Cowboys, say, or the Rangers or the Mavericks. We also want to try to understand or use this to increase our retention. So obviously, if we have more engaged customers who are focusing in on that particular content, and we can get them to the right story at the right time, we're going to see an improvement of subscribers staying with us longer, as well as driving an increase in the new subscriptions. We also want to see how well here we focused on the content as a whole, but we also want to zero in on something that's important to our newsroom in particular, that has to do with the best headline that we can ultimately get, and what are some of the words that necessarily drive people to click, and then after that stay engaged and continue reading the article. After that, we also want to see, can we make this more robust? So ideally, we want this segmentation to happen real time, that as people come to our site and we learn more about them, so right off the bat, we'll know, for instance, that what type of device they're using, where they're coming from, what was the first article that drove them here. And so we want to try to find ways to dynamically feed that same algorithm. So as the person stays on the site and looks at more pages, we can ultimately get an even better classification for them and maybe realize that they weren't initially in the segment that we thought, but in another segment, and then how would we adjust the content experience to account for that. And then obviously we recognize that the types of content are going to evolve over time. The sort of articles that people read a couple of years ago are not necessarily the primary articles that they might want to focus on today. So we want to use this algorithm to see how that changes over time. What sort of new content is popping up to the top, and what sort of content is maybe something we should report on less frequently. So those are some of the things that we aspire to, but with what we have right now, what are some practical recommendations? And so this actually touches in a lot of different areas at the Dallas Morning News. So newsroom strategy. We certainly don't want to dictate to our newsroom or take on any sort of editorial role. But we can help out the newsroom by providing them with more information on what different sites people are going to, what kind of content they're reading, and so on. And so then the newsroom can make adjustments as they see fit. The other thing that this can help with is journalists are in some ways sort of their own concern in that they yes, work for a paper, but they also have social clout in and of themselves. And so many of them are driven to not just produce run-of-the-mill journalism that's going to be read by local customers, but to try to write the articles that are going to have a broad reach and expand throughout the country, say. And so this can help them understand, particularly around what causes articles to go viral and how could it help them if it did. Advertising, of course, is always going to be huge with media, and so we're going to want to make sure that we're putting the best advertisements in the right place in a real-time fashion. And so to the extent that this segmentation can inform us of better ways to deliver the advertising, then all the better. Also, once we see that certain sections or certain types of articles are more likely to produce engagement, we're going to want to use that to potentially alter our website to make certain content more easily findable, if you will, and others maybe more specifically for niche markets, right? Are there areas that we might want to focus in on, certain regions or certain parts of town that are unique? And then lastly, our website, like many media websites today, not only do we derive revenue from advertising, but we also derive it from subscriptions, and digital subscriptions are a very important thing. And so I'm sure all of you run into a situation where a little box pops up at the top saying that you've got 2 more free articles this month or 3 more free articles, and that's called a meter. And so taking a one-size-fits-all approach with a meter doesn't really make sense. Ideally, you want to have the meter set relatively low for people who are likely to become subscribers, and perhaps set relatively high for those who are maybe sort of just visiting from, say, an out-of-state location and are not a good prospect for becoming a subscriber. But by setting that meter a little bit higher, we can actually get some advertising revenue if they're not going to become a subscriber. So a lot of different ways that this can ultimately impact the paper and how we make decisions on that. All right, well, with that, I think John and I will now take any questions that you might have.
Great. So we, as we wait for some more questions, what the initial question might be would be that you've done this segmentation based upon articles. Traditionally, segmentations are segmentations of customers. How do you anticipate the success of that? Dustin, what do you think about that?
I think that's definitely going to be something much more impactful in a lot of ways. You can talk about content and what the best strategy is for that content, but at the end of the day, the content's not the subscriber. The subscriber is the subscriber. And so to the extent that we can segment those customers and be able to spot someone, kind of like the example I gave earlier of someone who reads different types of articles when they're at work versus at home, that'll give us much more power to be able to sort of craft something specific to them so that we can make sure that not just the right articles, but at the right time of day, they see the sort of things that they're focusing on. So we're anticipating that this will be quite big for the newsroom.
Yeah, and I think that the same methods that we use for segmenting articles in this case study would be used. The same methods really for segmenting people, segmenting customers and potential customers. Another question has to do with traditional segmentation. Really divides people into clusters or groups, and does this really do that? And I understand, and so let me address that one. We started this presentation by saying that the machine learning algorithms can accomplish the same goals as traditional segmentation in acquisition, retention, and so forth. And but it's also true that these this model, the random forest model, can produce actual clusters just like a traditional segmentation could. And that there's a methodology, because essentially everybody is put into a bucket in the bottom, and every tree in a whole group of trees that makes up a random forest model is essentially a clustering algorithm to put people into different groups. There's a way to summarize that out of this model and produce the most common groups as well. So that can be done, and then the groups can be profiled. Let's see if we have any more questions. I think that's about all of our questions for now. I think I'm going to go ahead and hand it back to Christy.
Thank you, John and Dustin, for a wonderful presentation. And thank you, everyone, for attending today's Insider Series webinar on machine learning segmentation. Our next Insider Series webinar will be on large-scale qualitative, also known as Big Qual, on March 28th. The presenters will be Clay Detloff and Bonnie Cannoli. And with that, have a wonderful rest of the day. Thank you.